Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we will go into amine. Amine is under nitrogen compound. So where amine is NH2 attached to a R group. So where nitrogen in amine has a lone pair of electron. So it's able to accept H+, where amine acts as a proton acceptor, which is a base under Bronsted-Lowry theory. So we can have two different kinds of amine. So where we could have aliphatic amine or aromatic amine. So where aliphatic amine, it's NH2 attached to a straight chain carbon. Like where we have here, the carbon chain is with 2 carbons. And aromatic amine, it's NH2 attached to a benzene ring. So how could we name them? So for aliphatic amine, so we got to count the number of carbon atoms in the straight chain carbon. Like here we have 2 carbons in a straight chain. So we could actually put it into ethyl, where it stands for 2 carbons in a straight chain, and end with amine. So it is ethyl amine. So what if the NH2 is attached to a benzene ring? So what happened here? If benzene as a branch, we'll name it as phenyl, and it end with amine. So it is phenyl amine. So we could also classify amine into primary, secondary, and tertiary amine. So where we focus on the nitrogen, where if it is bonded to one R group, which is an alkyl group, and 2H, so it is a primary amine. So what if the N is bonded to 2R, 2 alkyl group, and 1H? So it is a secondary amine. So the last one to go, if the N is bonded to 3R, so 3 alkyl group, so it will be a tertiary amine. These are reactions to form aliphatic amine. So where the very first one, we have formation of amine from halogenol alkane. So this is the reaction of halogenol alkane, where it undergo nucleophilic substitution, where ammonia is the nucleophile. So the condition to go, it is concentrated NH3 aqueous with the condition in ethanol and heat. So where NH3 is the nucleophile. So it will substitute the Cl to give us amine as the product. So the next to go, we have reduction of nitrile. So nitrile is a functional group where we have CN attached to an alkyl group. So where nitrile will undergo reduction to give us amine. So where for the reduction to go, we could have lithium aluminum hydride in dry ethyl, or hydrogen with nickel, or sodium borohydride in aqueous to act as a reducing agent. So they could reduce nitrile to amine as the product, where we could see the C of the nitrile will gain hydrogen. And next, the nitrogen of nitrile will gain hydrogen atoms as well to form amine as the product. So the last one to go, we have reduction of amide. So amide is a functional group with C double bond O that bonded to NH2. So amide could undergo reduction with lithium aluminum hydride in dry ethyl as the reducing agent. So we could see the C double bond O it's losing oxygen and gain hydrogen atoms in the reduction. So these are formation of aliphatic amine. Next to go, it's formation of aromatic amine. So where we have phenylamine here. So to get phenylamine, we could make use of nitrobenzene. So nitrobenzene will undergo reduction to give us phenylamine. So where we have thin and concentrated HCl as the reducing agent to reduce nitrobenzene to phenylamine. And here we could see the nitrogen lost oxygen and gain hydrogen atom in this reduction. So next, we could have the next reagent, which is NaOH aqueous. So after reduction of nitrobenzene to phenylamine, so phenylamine could actually react with concentrated HCl to give us a salt as the product. So what if we want to get the phenylamine from its salt? We could actually make use of a strong alkaline. For example, here we use NaOH aqueous to displace phenylamine from its salt. So therefore, if the question is asking for the reagent where it requires 2 marks, so we could actually give this followed by NaOH aqueous for the second mark. So if it's just a mark question for a 1 mark, so we could actually just give tin plus concentrated HCl. After formation of amine, next we'll move into reaction of phenylamine. So where we have a benzene ring in phenylamine. So the benzene ring in phenylamine will react with Br2 aqueous under electrophilic substitution reaction. So where NH2 is the electron donating, so it donates electron to the benzene ring. So it would activate the ring in electrophilic substitution reaction. So therefore, this reaction doesn't require catalyst. So the reagent is just Br2 aqueous in room temperature. So we could have tri-substitution to have 2, 4, 6 tri-bromo-phenylamine as the product. So this reaction could give us 2 observations. So where we could have brown solution of Br2 aqueous turns colorless, decolorizes, and next we could see white solid it's from, and it is from 2,4,6 tribromophenol. So the next reaction for phenylamine is formation of diazonium ion. So where it is a reaction of phenylamine with nitrous acid. So the reagent to go, we could have HNO2 with HCl or NaNO2 with HCl, where NaNO2 with HCl, we could get nitrous acid and NaCl. So this is what we need for the reaction. So the product here, we could see it is diazonium ion. So here we have condition for this reaction to go where it should be in 0 to 10 degrees Celsius. Reason is diazonium ion will decompose when temperature is greater than 10 degrees Celsius. So with this condition and reagent, we could get diazonium chloride as the product.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.